So in the next couple of videos, we'll be looking at the normal distribution. So the normal distribution is a continuous distribution, which means that it defines probabilities for a continuous random variable. And your continuous random variable is going to take on continuous values as opposed to your discrete random variables that take on discrete values. So a discrete values, like we looked at in the previous topic, is 1, 2, 3, 4, and so on. It's an exact value. Whereas a continuous value, for example, the number 2, if 2 is continuous, it would represent the range from 1.5 to 2.5. So whenever we have a 2 under a continuous distribution, this 2 means any value between 1.5 and 2.5. And so we use the normal distribution for continuous quantities such as your height or your weight or time. Because for example, your height, you might be 173 centimeters, right? But if we're saying that you're 173 centimeters, you're probably not exactly 173 centimeters. Chances are, when you say you're 173 centimeters, you're probably between 172.5 and 173.5 centimeters. So this means that this is a continuous value. It's representing a range from 172.5 to 173.5. And so if the random variable x is normally distributed, we use this notation. X follows a normal distribution with mean mu. This letter is a Greek letter, it's pronounced mu, alright, and variance sigma squared. But to calculate our normal probabilities, it's different to how we did it for, say, the binomial distribution or a geometric distribution, where you had a formula that you would use to evaluate this probability. For us to be able to calculate normal probabilities, we actually want to move to what we call the standard normal distribution. And this is represented by the random variable z, which follows a normal distribution, and it has a mean of 0 and a standard deviation and therefore variance of 1. Okay, so we use the standard normal distribution to calculate our probabilities. So it means if you've got your random variable x, you're going to have to convert this random variable x to the standard normal distribution. We'll look at examples of how we do that in later videos, but generally the formula that you use is that z is equal to x minus mu over sigma, where mu is the mean and sigma is your standard deviation. And once you have converted your distribution to the standard normal distribution, we can then use the standard normal distribution tables to help us evaluate our probabilities. And typically the shape of a normal distribution curve looks like a bell curve, so it looks like this. Right, and we've got our x-axis or z. This is the typical shape that you get for a normal distribution curve. So for the standard normal distribution z, the mean here is going to be 0 and the standard deviation is 1. Alright, so that's the introduction to the normal distribution. Make sure to go through the quiz and I'll see you in the next video.